Welcome to tonight's video on a continuation of 2.6. We're going to go in further detail about holes and limits when we're graphing the rational functions. So the first thing you want to do when you're graphing a rational function is factor. So the factors of x squared minus x minus 2 is x minus 2 and x plus 1. And then the factors of the denominator are x minus 3 and x plus 1, which means when you simplify, you get that the function is equal to x minus 2 over x minus 3. So that is now what you will graph. So the first thing you want to do is find the vertical asymptote. And remember, that's what the denominator makes the denominator equal to 0, and that's at x equals 3. A hole happens when you simplify the original. So the factor that you crossed out was x plus 1, so that means the hole is going to be at x equals negative 1. To figure out the y value of the hole, you take that negative 1 and you put it into the simplified version. And you get negative 3 over negative 4, which is positive 3/4. So at negative 1 and positive 3/4, that's where you have a hole. The horizontal asymptote, the degrees are the same, so you divide the leading coefficients. And it's at y equals 1. That means there's no slant asymptote. And so you're done with the first part. Second part, the x-intercepts. That means you set the numerator equal to 0, so x minus 2 equals 0. So x equals 2, so the x-intercept is 2, 0. And the y-intercept, you put 0 in for x. So you get 0 and positive 2/3. So then you want to figure out if the horizontal asymptote crossed, so you set 1 equal to x minus 2 over x minus 3 when you multiply to get rid of the fraction. You get x minus 3 equals x minus 2. That means that negative 3 is equal to negative 2, which means it is not crossed. Step 4 is to graph this. So you graph your vertical asymptote at x equals 3, your horizontal asymptote at y equals 1, your x-intercept at 2, 0, your y-intercept at 0 and 3/4. And then the hole, 0 and 2/3. The hole is at negative 1 and 3/4, which means you have an open circle right there. Now, that means the graph is going to go towards the asymptote here. And then on the other side of the hole, it's going to go towards the horizontal asymptote there. The thing is, we need to know what it does on the right-hand side of the asymptote, so we put in 4. So 4 minus 2 over 4 minus 3. 2 over 1 is 2. So that means 4, 2 is a point. And it's going to go towards the asymptote that way and towards the asymptote that way. So there's our graph. Now the last thing you need to do is you need to find the limits. The end behavior limits are the limits of the function as x approaches negative infinity, meaning as x goes to the left. What is y doing? Well, notice y is going towards the horizontal asymptote of 1. And the limit of the function as x goes toward positive infinity, well, positive infinity goes out this way, y is going towards positive 1 again. There are also the asymptote limits. For each vertical asymptote, you have 2 limits. So as it approaches 3 from the left-hand side, notice it's going down, so it's going to be negative infinity. And as it approaches 3 from the right, notice from the right it's going up, so it's going to be to positive infinity. For the vertical asymptote limits, it's either going to go towards negative infinity or positive infinity because it either goes up or down forever. For the end behavior, if there's a horizontal asymptote, it'll go towards that. If there's a slant asymptote, then it's going to go towards negative or positive infinity as well. All right, so let's try the second one. Remember, factoring. So 2x squared plus 5x minus 3, factors of negative 6, which add to 5, are positive 6 and negative 1. So you can make it 2x plus 6 and 2x minus 1, which means you're going to divide by the common factor, which means x plus 3 times 2x minus 1. And then when you factor x squared plus 5x plus 6, it gives you x plus 3 times x plus 2. The x plus 3's cancel, so your new function is 2x minus 1 over x plus 2. That means that there's a vertical asymptote at x equals negative 2. There's a hole at x equals negative 3, and when you put negative 3 back in, it's going to be negative 7 over negative 1, or 7. Horizontal asymptote at y equals 2, which means there's no slant asymptote. For the X-intercept, you set the numerator equal to 0. So the X-intercept is at 1/2 comma 0. The Y-intercept is when you put 0 in. And you get negative 1/2. For the y-intercept. Then you have to look and see, does the horizontal asymptote get crossed? The horizontal asymptote is 2, so then it's 2x minus 1 over x plus 2. You multiply. Cancel, so you have 2x plus 4 equals 2x minus 1. So it's 4 equals negative 1, which means the horizontal asymptote is not crossed. So when you graph, you got a vertical asymptote at x equals negative 2, a horizontal asymptote at y equals 2, the x-intercept of 1/2 0 right there, and the y-intercept of 0 and negative 1/2 there, and the whole of negative 3, 7, which is right there. So the intercepts are going to take it towards the vertical asymptote there and the horizontal asymptote there. And then the good part about the whole being over here is that it means we don't have to substitute in a point because it's going to go up forever and then down forever there. So when we do limits, the last thing, and we look at our end behavior limits, the limit as the function as x goes towards negative infinity, and the limit of the function as x goes towards positive infinity. As you look towards them, at negative infinity, it goes towards 2, and positive infinity, it's going to go towards 2. And then for the vertical asymptote, the limit of the function as x approaches negative 3, I believe, is or negative 2, sorry. Negative 2 from the left, and the limit of the function as x approaches negative 2 from the right. From the left, it's going up. From the right, it's going down. So from the left, it's going up towards infinity. The right, it's going down towards negative infinity. All right. We're going to skip this one. And then when we talk about the sum and difference of two cubes, notice we have formulas here. We have the formulas for the sum and difference of two cubes, a to the third plus b to the third, and a to the third minus b to the third. Notice the pattern is the same. The only difference is the signs. The signs are the same in the first grouping, then it's opposite, then it's positive. So it's always a, and then b, and then a squared, ab, and b squared. So to factor x to the third minus 1, you use the fact that a is x and b is 1, because those are the cube roots. So x to the third minus 1 becomes x minus 1 times x squared plus 1 times x, which is x, plus 1 squared, which is 1. Then that's over x minus 2 times x plus 2. Nothing cancels out here. So when we do this, the vertical asymptotes are at x equals 2 and x equals negative 2. There is no hole since you didn't cancel anything out. There's no horizontal asymptote. So there's a slant asymptote because the degree of the numerator is bigger than the denominator by 1. So that means you got to do long division, which means x squared. Now there's 0x minus 4, and then there's x to the third plus 0x squared plus 0x minus 1. Well, x times x squared will give you x to the third. Then you multiply. Then you subtract. Remember, when you subtract, it's like adding the opposite. So when you add here, they cancel out, and you get 4x minus 1. If you notice, 4x is less than x squared as far as degree, so that means your slant asymptote is just the line y equals x. Now, the x-intercepts. Set the numerator equal to 0. So you get x to the third is equal to 1. The cube root of 1 is just 1. It's not plus or minus because it's not an even root. So the x-intercept is at 1, 0. The y-intercept, you go 0 to the third minus 1 over 0 squared minus 4. So you get 1/4. Then to see where the horizontal or the slant asymptote is crossed, if it is, you set the slant asymptote equal to the function. When you multiply, you get x squared minus 4x equals x to the third, it's x to the third minus 4x, not x squared, equals x to the third minus 1. Notice you get negative 4x equals negative 1. So x is equal to 1/4. So it is crossed because you get an x value. Since the slant asymptote is y equals x, that means it's crossed at 1/4 and 1/4. Because it's y equals x. So it's y, whatever x is, y has to be the same. So when you graph this, you have vertical asymptotes at -2 and +2. You have a slant asymptote at y equals x. So that means the x-intercept is 0 and you go up 1/1. So it's just going to, the slope is going to be 1. So it's just going to be a dotted line going through the origin with a slope of 1. So that's y equals x. The x-intercept is at 1, 0, which means it's right here. The y-intercept is at 0, 1/4, which is there. And that's all you know. What you do know is that the asymptote also gets crossed at 1/4, 1/4. So you know it goes towards the vertical asymptote here, crosses the slant asymptote, and then has to go up that way. Because the only place it crosses the slant asymptote is at that 1/4, 1/4. Then you need to put in some numbers, like, for example, 3. So 3 to the third minus 1 over 3 squared minus 4. So you get 26 over 5. So 5 and 1/6. 5 and 1/5. Doesn't want me to put the point there. Okay. So that means it's going to go up towards the asymptote there and slide with the slant asymptote going out. Likewise, if I put f of -3, -3 to the third minus 1 over -3 squared minus 4, so you get -28 over 5. So it's -5 3/5. So it's 1, 2, 3, 4, 5 down right there. So it's going to slide with the slant asymptote here, go down with the vertical there, and there's your graph. So now when you do the limits for the end behavior, as x goes to -infinity and x goes to +infinity. So as it goes towards -infinity, it goes down with the asymptote. Towards +infinity, it's going up with the slant asymptote. So it's going to go down to the left. It's going to go up to the right. Now with the vertical asymptotes, there's 2 limits for each. So the first vertical asymptote's at -2. So you go from the left and from the right at -2. So at -2 from the left, notice it's going down with the vertical asymptote here. And -2 from the right, it's going up. So when we fill that in, from the left it's going down, from the right it's going up. And then at +2 we also have a vertical asymptote. So we go +2 from the left and +2 from the right. So if we look, +2 from the left is going down, on the right it's going up. All right, so that's the concept of limits and holes added to our rational function graphing. Hope you enjoyed the video, and I will see you in class. Have a good evening.